a software engineer at Arista Networks, and today we're going to look at how EOS, the Arista operating system, integrates into Apache Hadoop. So we're building this feature called MapReduce TraceR that allows us to provide visibility into Hadoop workloads. As the Hadoop jobs are dynamic and changing and moving all over the cluster, it's really hard for a network operator to really understand where the jobs are and what they're doing. So what we have in this little demo is a very simple setup with 2 racks and 16 machines on each side. And each machine has a data node and a task tracker as usual. And we also have our name node and job tracker. We configure the top of rack switch with the information to find the job tracker. And from there on, the top of rack switch is able to locate all the nodes in the cluster and keep a watch of all the jobs that are running in the cluster. The switch will then focus on the jobs that are running locally on the machines that are locally connected to the switch. This will allow us to provide visibility into the jobs that are running locally within each rack and provide statistics on their activity and how they impact the network. So let's look at how this works. We have our switch here, which is one of the 2 top of racks that's configured for Hadoop TraceR, and we can get basic information about the state of the cluster. So we are configured to talk to one Hadoop cluster here, and we can see the cluster summary, which is very similar to what you would see if you were to look at the web interface of the job tracker. So we can see we have a number of task trackers, and we can see that we are currently running a number of MapReduce tasks. Let's take a look at what those jobs are. So we currently have 5 jobs running across the cluster, and we can see there are progress both for the map phase and the reduce phase across the entire cluster. Now what's interesting is that we can look at the activity of the machines that are locally connected to us right now. And the way we would do this is by, first of all, identifying what task trackers are connected to this particular switch. So we can see here that on this particular switch we currently have 14 active task trackers that are busy executing map tasks and reduce tasks. We can get a quick sense of what jobs are running and how much data they are sending over the network by looking at the job counters that are exposed by the MapReduce framework. So the switch is continuously polling the job tracker and accessing information about the jobs that are running right now and their progress. So for our 5 jobs, we can see the amount of data that those jobs have sent and received over the network within this particular rack. So what's interesting here is that we really focus on the activity within a rack. We can also look at what's happening on a particular node behind a particular interface. So we can do this easily by specifying either a host name or an interface name. So for instance, if I want to see what's going on behind the interface ET1, I can see not only the IP address and the name of the task tracker, but I can also see what tasks it's executing right now. So in this example, we can see that this task tracker is executing a variety of different tasks for 3 different jobs, and we can see that those are all reduced tasks at the moment. And we can also dig into an individual task by looking at their counters. So for instance, if I want to look at the status of this task here for the job ID 34 and task ID 149, I would do this, and I could get the information about this particular task. If we can look at maybe a task that has made a little more progress, maybe this one, and we can see that this one just started to shuffle, the shuffle phase of the MapReduce job. And we also have progress information as far as the copy and the sort phase of the MapReduce job. So this really helps to understand what's happening inside of the Hadoop cluster, what tasks are executing locally, and what progress they're making. We can see, for instance, right now that one of the jobs we were looking at earlier has now completed, so it's no longer running within this rack. So the first phase of this feature is really about providing visibility into the activity of the Hadoop cluster. We regularly poll statistics about Hadoop activity and to know what jobs are running, when and where, and get a sense of how big each job is network-wise. We then provide historical information about the MapReduce activity so that it's easy to troubleshoot problems after the fact. This really provides real-time visibility into the CLI for network operators who may not otherwise have access to the Hadoop infrastructure. We intend to support multiple clusters running concurrently on a given switch, and we are also compatible with a broad range of Hadoop flavors and versions and distributions. Most importantly, we support the Apache Hadoop from upstream, as well as various distributions such as Cloudera's or Hortonworks. So this is it. This is MapReduce Tracer for Arista iOS.